So, hello students. In this lecture, we are going to cover part B of unit number 6, that is matrix inversion. So, first we are going to study matrix inversion using Gauss Jordan method. So, earlier also we have studied Gauss Jordan method, but that method was Gauss Jordan elimination method, and now we are going to study Gauss Jordan method to find the inverse of an matrix. So these are the steps given to solve or in order to find the inverse of an matrix. So see here, when the matrix A is given, then we have to form an augmented matrix, that is A augmented I. A is the given matrix and I is the identity matrix or the unit matrix of the order that of A. Suppose A is of order 3 by 3, then we have to form here an identity matrix of the order 3 by 3. And now we have to apply here row transformation to convert this augmented matrix, that is A augmented I, into the form I augmented A inverse. So we have to convert this A into the identity matrix, and we will get on the right hand side, that is A inverse, and that will be our answer. So let us see one example related to this Gauss Jordan method. So see here, find A inverse using Gauss Jordan method. A equal to they have given these values 1 3 3 1 4 3 1 3 4. This particular example was asked in 2019 in the university question paper for the 6 marks. So see here, this is a very simple method. Already we have studied the row transformation, so again we have to apply that in order to find this A inverse. So see here, first step is we have to form an augmented matrix, that is A augmented I. So see here, I have written A augmented I. Matrix A values will be written as it is here, that is 1 3 3 1 4 3 1 3 4, and whereas we have to write here an identity matrix, that is 1 0 0 0 1 0 0 0 1. Now what we have to do? We have to apply some row transformation on this matrix A, and whenever we are applying some transformation on this matrix A, this particular side will going to change, and this will be our answer, and this will be nothing but the A inverse. So see here, we have to make this particular matrix A into an identity matrix. We have to convert this matrix A into an identity matrix. So we are going to apply some row transformation to this matrix A. So see here, what we have to do here. So first see here, this is my diagonal element, first diagonal element, it is 1 here. So I require 1 only here, so I will keep it unchanged. But with the help of this diagonal element 1, I am going to make the elements below it, that is this one and this one, I am going to make it 0. So I will perform the row transformation, that is R2 minus R1. See here, R2 minus R1. So after performing this, we will get the answer like this. So see here, whenever I am going to perform here R2 minus R1, always note that the effect will be only on the row 2. Row 2 will change only. The change will be seen only on the row 2, whereas row 1 as well as row 3, these are unchanged. So always prefer to write this row number 1 as it is, row number 3 as it is, and row number is row 2 is changing here, so write it afterwards after the performing the calculations. So see here, R2 minus R1, so 1 minus 1 0, 4 minus 3 1, 3 minus 3 0, on this side 0 minus 1 minus 1, 1 minus 0 1, 0 minus 0 0. So we have performed this R2 minus R1. Now next step is we have to make this element, that is this is my A31, that is 1 here. So I have to make this 0. So how can I make it 0? again with the help of this 1 only. So I will perform R3 minus R1. So see here I am going to perform R3 minus R1. So see here 1 minus 1 it will be 0, 3 minus 3 it will be 0, 4 minus 3 it will be 1, 0 minus 1 it will be minus 1, 0 minus 0 it will be 0, 1 minus 0 it will be 1. So see here we have, so this is my first diagonal element, and I have converted the elements under this diagonal element to 0. So now what we have to do? Now the second step is, now the next step is the second diagonal element. I have to convert this to 1, but again by default it is 1 here, so no need to convert it to 1, and the element below it is also 0, so no need to convert it to 0 again, but the element above this, one is 3, so we have to make it 0. So see here we have to perform here R1 minus 3R2 in order to make this 3 as 0. So after performing this R1 minus 3R2 we have got here 0, and similarly this particular side has also changed to 4 minus 3 and 0. Now the next step is what we have to do. This is my third diagonal element, and this is 1 here. If it is not 1 then you have to make it 1, but in our example it is already 1, so we have, with the help of this third diagonal element, we have to make the elements above it to 0. So which are the elements above it? These are 0 and 3. So this particular element is already 0, so no need to convert it, but we have to make this 3 as 0. So we have to apply here, we have to perform R1 minus 3R3. So see on the next page. So see here we are going to perform R1 minus 3R3, and after performing this we have make this particular term to 0, and after applying the row transformation this particular values has also been changed. Earlier it was 4, so it has changed to 7. This is minus 3 only, and this is a minus 3. So see here we have converted the given matrix into the identity matrix. We have converted it into the identity matrix, and this is nothing but the A inverse of the given matrix. So in this way we have found out the answer, that is we have found out the value of A inverse. So we can write here, after writing this A augmented A in A inverse, after writing this we can directly write A inverse is equal to this value, that is 7 minus 3 minus 3 minus 1 1 0 minus 1 0 1. So this is the inverse of the given matrix. So this will be asked for 6 marks in the university. So we will conclude today's lecture. In next lecture we will see one more example of this Gauss Jordan method. Till then, thank you.